There's little hesitation in saying that one of the most remarkable developments in astrobiology over the last few decades has been the discovery of planets orbiting other stars, exoplanets. And we're going to have a look at some of the methods that people use to look for these planets and some of the recent discoveries. It's worth remembering that speculations about the possibility of planets orbiting other stars goes back a very long time. Giordano Bruno said in the 16th century, "In space there are countless constellations, suns and planets. We see only the suns because they give light. The planets remain invisible, for they are small and dark. There are also numberless Earths circling around their suns." Well, unfortunately, Bruno was burned at the stake in 1600, not just for his astrobiological speculations, but also because he did other things that irritated his religious superiors. But nevertheless, his speculations about the possibility of planets orbiting other stars, even Earth-like planets, was truly remarkable. The search for planets around other stars really became an empirical science in the late 20th century. In 1992, two radio astronomers announced the discovery of two planets orbiting a pulsar, a rotating neutron star. And in 1995, Michel Mayor and Didier Queloz at the University of Geneva announced the first definitive detection of an exoplanet orbiting a main sequence star, a G-type star called 51 Pegasi. These discoveries ushered in the era of the search for extrasolar planets. And now many of these planets are known and continue to be discovered every day. The holy grail for astrobiologists, at least, is to try and find a second Earth, a planet identical, maybe, to Earth in terms of having life and habitable conditions, that may be orbiting a distant star, to be able to detect that planet and study its composition, its atmospheric composition, and the conditions that it might have to sustain life. The search for planets around other stars has focused on main sequence stars. If we plot stars according to their luminosity and their temperature, we end up with a band of stars that you can see in the center of this diagram, the Hertzsprung-Russell diagram. And the majority of planets that we might be looking for are orbiting these so-called main sequence stars. One method that we can use to look for planets around stars is the transit method. When a planet orbits around its star, some of these planets, if they're in the field of view of the observer, will pass in front of the star and block out its light. As they block out the light, if you're measuring the light from that star, you'll see a dip in the light given off. And this dip can tell you that there's a planet there and something about the nature of the planet orbiting the star. This is an example of a light curve from a planet that has transited in front of a star. And you can see very clearly the light of the star continues quite continuously along the top of the graph and then drops when the planet passes in front of it. This is one method used to search for extrasolar planets. Another method to search for planets is called astrometry. And the best way to think about this is to think about two people holding hands and swirling round each other. When two people hold hands and begin to circle around each other, they will circle around a common centre of mass. And we can use the same sort of method to search for planets around other stars. If a planet is orbiting around a star, they will in fact circle around the common centre of mass. And the centre of mass will not be exactly in the centre of the star, because of the mass of the planet. In fact, the star will wobble ever so slightly as the planet and the star revolve around their common centre of mass. This wobble in the planet can be detected and used to infer the presence of a planet. It needs very high sensitivity, but telescopes can be constructed to find planets by the astrometry method. Another method that we can use is called Doppler shift. This rotation of a planet around a star that causes this wobbling will also cause a slight change in the wavelength of light given off by a star. As the star moves away from the observer, the light will be slightly shifted towards the red. And as the star moves towards the observer, the light will be slightly shifted to the blue. This wobbling caused by the presence of a planet around a star can therefore be detected by the slight change in the wavelength of the star. And this method, called radial velocity or Doppler shift, has been very effective in being used to find extrasolar planets. And by mid-2011, over 500 stars had been detected using the Doppler shift method. Yet another method that has recently been developed is called gravitational lensing. And the idea here is that a star will distort the light from stars or galaxies behind it. This is because of the gravitational influence on the light being bent around the star, first predicted by Einstein. So instead of seeing distant stars behind stars that you're observing, the light will be distorted and you'll start to see a sort of blurred image, almost a ring if you like, of the light that has been deflected from a distant star around the star that you're interested in. If there's a planet in the way, a planet orbiting that star, it will have a very subtle effect on the light that's being distorted from distant stars, and that subtle effect can be picked up and again used to infer the presence of a planet orbiting that star. Gravitational lensing is a new method, but it's being used very effectively for finding exoplanets orbiting distant stars. So what have we learned in this brief review? Well, we've learned that there are different ways to find planets around other stars. Each method has some advantages and disadvantages, but taken together they allow us to search for a large number of planets orbiting around other stars.